Okay, so that fits good. I will also talk about motion, the motion signal that I have been working on already since my early days. And I changed it a little bit. I said 3D motion analysis with motion signals. And what? Okay, and why? Because motion analysis has come a very long way. We know approaches that they're working, they are used, but the approaches general, we still think about it that the sensor, our camera, our video camera takes frames. And in these frames, the dominant approach is we're taking point correspondences between these frames. Or if they're very close together, these point correspondences become optic flow. And then from this, we relate them to the geometry in order to get how the sensor is moving and what is the scene in view that we are seeing. But it's basically still a static view, a bunch of frames. And biological vision systems they work with motion directly. We know even that lower systems, reptiles, for example, can only see motion. They can't interpret static images. And so from an early, when I was already in my PhD thesis, I wanted to explore this motion signal. At that time, we didn't have sensors, and I was working with so-called normal flow. But let me show you first this other slide. So this is basically the dominant approach nowadays. It is called the SLAM approach, which is now modeling the motion estimation in a probabilistic way. We compute these correspondences, we hypothesize what we would see, what is the motion, and on the basis of the hypothesis, then we keep updating. And by keeping it probabilistic and keeping it updating in a way, this way taking over time, it becomes much more stable, but it remains this kind of static view. The approach does work well, but as you know, especially in the automotive industry, independent driving, it's usually a very heavy sensors involved in many approaches, LiDAR doing a lot of work, but of course, other companies are going also with vision. Each of these sensors, a combination, usually in car driving, there's a combination of sensors, each of them tuned to a specific range of depths.